So anyway, I'm revisiting the 50 cal design, the pistol, which worked fine, but it was cumbersome and it was too long. This layout will be a more traditional with the fill port in front, the trigger sear, preventing a hammer going forward, and normal transfer port that's vertical and makes a 90 degree, and it'll have some extensions connecting this forward rod to the sear, and I'll get that all worked out. Kind of like the last one, but they'll be longer and maybe better looking. So a couple people have asked, how does the mechanism work internally? Normally with a balanced valve, let's say a Cochrane valve or one of the other balanced valves that people talk about on the forum, the bias is to keep the valve closed. In other words, to keep the poppet seated. And what I mean by bias is the diameter of the poppet, the sealing area, is larger than the diameter of the balance port or the balance chamber. And this way the air naturally acts on it to keep the valve closed until firing. When the hammer hits it, there is less cracking pressure because of the balanced valve. In this situation, with this being, the valve mechanism, the entire mechanism all in one, it's actually biased open. So the only thing holding it from firing is the sear, which in this case, I don't know what gun this is off of, that little tab right there. So, that's what's keeping it closed. Let me open it up real quick and show you the general layout. Alright, so the way I had this sitting was like so, and this is the front. So we have the Foster nipple that feeds through the stem itself, and this is the rear sealing O-ring, which interfaces with the inside diameter. And then, as you can see, the Foster nipple fills in front of it, so all the air's inside and the O-ring's always behind the air pressure. So it fills through a long skinny hole and into here. This retainer is because when the gun fires, it actually, for a split second, not a long period of time, but it's very violent. With the spool itself firing backwards, it slams into this rear cap. And my original design was just a screw through the rod. And what happened was that eventually sheared and started digging into the aluminum inner wall of this piece and causing leaks. So in this case, it's a ring, it's double pinned, and so that ring slams into this, and so far that's been reliable. Moving up front, this seal would inevitably blow off after a couple shots, so I actually made the front of the O-ring seal adjustable. So I know how this interfaces with the poppet seat, which is up here. I know how that interfaces, but how the O-ring interfaces and how much it protrudes beyond the diameter of the spool makes a big difference as to whether or not it stays in place. With this adjustable system, it stayed in place and I fired it at least 8 times today. And that's basically it. So the air pressure builds. This is seated right in here, right near the transfer port. It's seated in a hole of similar diameter. And as the pressure builds, because the seal back here, the seal back there is a greater diameter, this wants to be pulled this way, or pushed rather, and it wants to pull this seal out of its seat, causing it to fire. And the only thing stopping that is the connection out here that goes back to some sort of sear or impediment to it firing. And just by the nature of it, it's a violent firing cycle. I thought about doing a spring from this cap inside to this retainer, a spring in between there. But it might just go full auto. It might shoot and then recoil and then kind of shoot and just be a disaster that's hard to tune. So I'd rather it just be able to take the impact. And then that's about it. This will be, I don't know how I'm going to load it yet. It might just be muzzle load. I don't know. I might make a breech opening up here. But this will be the threaded transfer port that'll go down into here, and there'll be some sort of, some sort of bands connecting these, and long tie rods going from the front end of the spool back to the sear of the trigger mechanism. But that's basically it. It's not a complicated gun, but the power potential, being direct fire is, far beyond. I wouldn't say it's far beyond. It's comparable to any other gun, by volume and by barrel length. It's going to be at the maximum of what's achievable. It's low efficiency. You're using all the air in one shot, even if that's not optimal. But as far as power goes, this system is really maximizing it, because you can have full bore porting, which is difficult with a conventional loaded gun, like let's say a Crosman 2240. If you had full bore porting, you just have a hard time pushing the pellet past the probe. Pushing the probe and the pellet past the transfer port, and stuff like that. Not to mention, there's diminishing returns. There's only so much volume of air or CO2 you can put into a certain bore of transfer port without a pressure drop. So that all needs to be, factored into the equation. With this, it's, for lack of a better term, it's balls to the wall instantly, full bore porting, and whatever's going to happen is going to happen, because everything's out of the way. You don't have a stem crossing through the throat of a valve. Once this moves back, that's it. Everything in here can head for the exit. Once this moves back, everything, it's a free-for-all. It's all heading for the pellet, or the lead round ball in this case. So anyway, I hope that clarifies some of the inner workings.